last time we were discussing about same lessons that we were filling the gap between O levels and advanced level, the gap bridge. So we are bridging the gap, and this is the second lesson of the same, and we'll see some more algebraic relationships and their behaviors, which help us to tackle more advanced problems what we are going to see in our next course of journey. Then today I'm going to discuss another important points in algebra which help us to solve more problems and tackle more problems in advanced level syllabus. Right. Then today we'll see how we are going to solve difference of scales. We know difference of scale means in this nature of equation. If my equation is a difference of two scalar variables, then how we are going to solve that, or how we are going to simplify that. With the first glance, with just seeing that one, we are not getting any idea how to tackle this, how to solve this, but we'll do some small manipulation and then we'll see further simplified version of this one, which lead us to solve, or which is useful as to solve further problems, or combined problems, where we can see difference of scales as well. Right. So what I'm going to do is I'll just add two numbers of this nature, AB and as well as AB and B square. What I have done is I added one AB number and another AB number, but with different signs. So we know from basics or from fundamentals, if we add and subtract same amount to a given equation, nothing will change and the equation behave the same manner as before. So that I am having the rights to use this equal sign further. But here I am seeing a relationship where for these two terms A is common and these two terms B is common. So what I'm going to do is I'll take A from this one, then within bracket I can write here A. If I take one A out from A square, then one A will remain, one A is remaining, and here B is remaining. And for the next term, I'll take B out and A minus B coming as my common factor. Right. By seeing this simplified equation, I can observe A minus B is my common factor. So what I'll do is I'll take A minus B out, and from first term A is common and from the second term B is common. So I'll end up with, now I'm finding two factors for this difference of scales. That for A squared minus B squared, I can factorize it further. Factorize means I can write in a simple terms in this nature. So this is one of the important point we should know when we are dealing with algebra, and this result we can use directly. We don't need to prove this. So this is one of the important relationship we derive and we should remember. So we can use this relationship directly if I am seeing any this nature relationship within my given problem, let's say. Yes. So after deriving this relationship, let's see how we can use this relationship, or how we can apply this to day-to-day problems. Day-to-day problems in the sense our exercises, or our problems we are getting with algebraic domain, algebraic what you can exercises, let's say. Yes. So first, let's try to solve. Sorry, I'm sorry. Let's try to solve this problem. So example 1. Yeah. Let's say yes, A3, A into power 3, and it multiplied with B, and next term is A and B into its third index, or third power. So it raised into 3. Whatever terms you are using, it gives you the same meaning. Right. With observing it carefully, we can see A and B, B term, A multiplied with B. AB term is common to both. So I can take AB term out. So here I took one A out and B out. So A square is remaining. And from this term, I took A out and one B out. So B square is remaining. So AB is one factor. Next, I know from the theory we learned just now, this one, the factors for difference of squares, A minus B, A squared minus B, I can write in two factors in this nature, right? Then this complex combination of A3B minus AB3 is simplified to three factors of AB, A minus B, and A plus B. And here we use the relationship what we derived, this 4. Right. Same way, we'll do some exercises to get familiarized with this. And the second one, let's say, yes, this one, x4, I'm sorry, x4 minus 1. x4 minus 1, right, directly we are not seeing any known relationships, because so far we have not learned about x into 4 and relationships or simplifications. But this x into 4, I can write like x4, sorry, I'm sorry, x2 into 2. From anyway, if this is a bit complicated, you can just believe my words and agree with me. For now, I can write this in this nature. Later on, that next lessons, we are going to learn about indices and logarithmic. There, we are seeing how this sort of manipulation is possible with indices. And A, yes, A I can write it in any form. Why? Because A into A1 is, sorry, I'm sorry, A1, 1 into 1 is 1, 1 into 2 is 1, 1 into 3 is 1, 1 into n is 1. Right. So, for this exercise purpose, this example purpose, I just raise A into 2. Why? Because I'm going to deal with difference of squares theory. Then what I can write is, okay, forget about what is inside this bracket, but just say, just assume, yeah, whatever inside is squared. So square of this minus square of this, then I can write using this combination x square minus 1, then x square plus 1 as this first stage solution for this combination. But the manipulation is not over yet because we know further simplification for this, as this again behave like a difference of scales. Right, we know from the previous stage, one I can write into any index, but here the requirement is index into 2. So by assuming that this is 1 is appearing as 1 into 2, directly I am writing this as two factors, that is x plus 1 and x minus 1. But to validate this equal sign, I have to take this term also to the next stage, next level. So x plus 1. So here, then this is my possible simplification for this, and thereafter I'm not seeing further simplifications for this relationship. So what I ended up with is my x4 into 1 can be simplified or factorized into this. So these are called or known as factors of this. Means if I subdivided or subtracted or I wrote this as multiplication of some other algebraic equations or algebraic expressions. Right. Okay. So this is application of my difference of scale relationship. Yeah. Okay. We see some more problems. Yeah. Let's check whether. Let's see if I write next corner. Yeah, you can see, right? If I write this corner. Okay. So the third one, here I'm just giving you ideas how to tackle or how to handle different sort of problems. Because even some problems are not directly giving you a path to solve, right? But this is the training you are getting. With this training, you train your brain to think differently. Oh, if you see this one here, you can argue with yourself, or you can struggle yourself, or brainstorm and see what are the possible methods to handle this. Yeah, for this one here. So far we learned about difference of scales, then some factorization, but with those theories, still I am not able to see any direct method to apply here. So what I'm thinking is, okay, what if I convert this to difference of scales? Are there any possible ways to segregate this or manipulate this or regenerate this in form of difference of scales? For that one, what I'll do is think about scaring something which gives me this as part of its solutions. I'm not telling you that the scaring will not give you the full solution, but part of this solution. Then that way we can try to put that problem into this domain, this area, or this nature. So here I'm not going to write the equal sign, but what I'll do is just check this. If I multiply this by itself, hope you can see this green color, right? If I multiply this expression by itself, that is carried, I know from my ordinary level knowledge, I'll get a into 4 plus then twice of this multiplication. That is this multiplication is 2 a square b square, then twice into it means 4, right? 4 a square into b square plus square of this whole term, that is 4b square. 4b square, right? Then by seeing this, I know, right? So by seeing this, I am getting an idea, all right. This expression is missing this center term, the middle term, that is 4a square b square. So what I'll do is the same way, the same manipulation what we have done here. So we added one term and we subtracted one. Other way, we added one term and we subtracted one term, and still my equal or the expressions are still valid. Why? Because this is nullifying my whole value of the equation, in the sense that this nullifies this one, so that whole value of the equation still remain the same. This same way, so I'm writing is 4 plus 4b square again, 4 again, why? Because here I need separate thing, then I'll write equal side, and what I'll do is, now my plan is to get whole square of this term. So what I need is 4a square b square term, then combining these three terms, I can write it as this simple relationship, but I'm adding this 4a square b square externally, extra addition, so that to get the validity, I have to subtract same from this equation. Right. Now, what I'm getting is, I'll handle this separately and I'll handle this separately. Right. I immediately, we can write this as a total square or whole square of this term. Means this can be written as a square plus 2b square into 2, or it's same, it multiplied with its same, its own value, but and right 4b square a square. I'm sorry, I just it changed the terms, but then okay, but still my requirement is, so I'm proceeding towards getting this sort of combination. Here, this the second term, it's a square of 2ab. It's a square of 2ab whole term. So what I'll do is, I'll write 2b square whole term minus 2ab whole term into 2. Right. See, my terms are valid and it equates to this. I have not done any extra addition. Whatever I added, I subtracted and I balanced the equation. Right. But this point, I can see here, this is sharing the same relationship of a square minus b square. So what I'll do is, now assuming taking this as one term and this as the another term, and I'll directly write the combination of or solution for differential square expansion. So my a is this a square plus 2b square, that plus 2ab. Right. Then next thing is a square plus 2b square minus 2ab. Yes. So this is my expansion or factorization for this relationship. I factorized this relation into two factors. of second order. Here is the order is 4, and I reduce that to second order. Mainly, purpose of this sort of exercises is to find out the values for these unknowns. Because so we are dealing with expressions or functions. I am the here the best term I can use is expressions, but not equations. But later on we discuss this sort of relationships as equations. When we are dealing with equations, the purpose of equation is to find out what are the possible values to fulfill this relationship or validate this equation or giving the proper relationship of left side to right side. So why? Because the equation we are using equal sign, and equal sign means okay, left to right should be equal. Alright. But next lesson we are learning about equation. But until we get the equation exercises, we are dealing with this sort of manipulations or factorization or simplification, which helps us to deal easily with equation lessons. Right. Okay, I'm going to erase this and you copied this part as well. And I'm going to see some more exercises to train you how to apply this relationship in different problems or different natures of problems. Right. Then we think about this sort of problems. 1 minus a square plus 2ab minus b square. My problem is this nature. Right. Still, I'm not seeing that, but we are discussing under difference of scarce module. But even though these exercises is given to explain this relationship, but in day-to-day life or in your other modules, you will get this sort of expression, but nobody will ask you to use difference or scarce. Nobody will give you the direct path to deal with. But by seeing this one, you should get the idea. All right, this sort of things. What possible methods I can apply to simplify, and with your experience and the knowledge, the way you with your way you train your brain, yeah, you are getting okay. This time, why can't I try difference class theory here? Yeah, yeah, you can. I'll do small manipulation. I'll just take minus out and keep this inside the bracket to show I'm going to address or deal this whole thing separately. So I'm taking minus out. So minus out from minus a square means inside this is positive. But here the positive, but I have taken minus 1 as common term, so that I have to take this as minus term, and here it is as positive term. These things you know, because to keep this validity, you have to make sure once you remove these brackets bases, you should get the same previous equation. So that's why I did this negative positive manipulation. We already familiar with. Right. Then this one, we know this one is this one is the expansion of this. From our previous knowledge, we know a minus b expansion is, but in general, the binomial, the two terms, expansion of two terms of this nature, we call binomial expansion. It's ended up with this square, and twice of this multiplication. Right here, see a square b square, and twice of this multiplication minus ab to 2. And as we discussed previously, a I can write in any nature of its index, because whatever index a one, sorry, not a, I'm sorry, one, whatever nature 1 raised to it ending up with 1, but it should be an integer, a whole number. But if it's a fraction, then result is different. It's a number between 0 and 1. Later on, we will discuss in advanced level initial, the first module. Then what I can do is I can write this here. This is like this form. Then directly difference from scarce theory. 1 minus whole thing a minus b. Why I am writing this bracket again? Otherwise, you will make a mistake of this expansion. But now I'm going to give you the theory and I'll train you. But later on, when you are doing real day-to-day exercises, you should not follow this stage, or you should not write, or I'm not expecting you to write this stage. And directly you should write the final stage. Here, since we are doing the first exercise of this nature, I'm giving this intermediate stage, but this is not a must one, and this is not the one you should follow. Next, right here, I'll expand these braces. I'll remove these braces by one, then one. This is positive, this is negative, then it end up with positive A, and this is positive, this is sorry, this is negative, this is negative, it end up with positive B. And here, but here it is easy, since positive is outside the bracket, so directly I can write whatever inside the bracket. See, initially we assumed, we thought, oh, right, it's a very complicated problem, but by using knowledge in two areas, how to deal with binomial expansion and how to deal with difference of scarce expansion, we ended up with a simple relationship of power 1, or it's a linear. Later on, we'll learn what the terms we are using for this sort of things is linear relationship or linear expression. So this quadratic or second order expression we simplify to first order or linear relationship. Then if we get any equations of this form, and if we ask to find out values for this A and B, this A and B are called unknowns or some variables in different problems or different modules or different sections. They use different terms, but ultimate aim is to find out values for this if it is an equation. But why we are learning this is to apply those things in solving equations. And I hope you understood the concept and how to apply the learned theory by in your so how to apply this learned theory in different applications. That's why I use different form of exercises or examples, and I hope with that those exercises it is clear to you the application of difference of scares. If you're having any doubt, you just message or talk to me or let me know. Otherwise, I'll move to the next section. Next part of the lesson. All right. So I'll erase this. You copy it, and we'll move to next theory. So I'm going a bit fast because it's not a new thing, but I'm just recalling your O-level knowledge and giving you a bit complicated or bit one level up exercises to train your brain to face complicated lessons coming in few days time. Right. I know in the theory for different squares. Let's move to next stage. Yeah, then we'll see how cubics are handled. Cubic in the sense, yeah, how to handle A3 plus B3 or A3 minus B3 factorization. Yeah, let's say factorization. How to factorize in cubic form. Still, this is binomial. It's a relationship of two numbers, two variables, but it's in cubic form. Right. Here, we are not seeing any direct method, or it's not coming into our mind. Yeah, we can use this, or we can use some specific method to expand this and find the factors. So what I'm going to do is, yeah, we'll do some trials, but trials in the sense that those things we mathematicians already do, right? But we'll see the same, we'll do the same thing to train ourselves. Yeah, let's say like this, A3 plus B3. I want to factorize it. So what I'll do is, we'll think about this. We'll think about this. What will be the expansion of this? See, I'm not using any equal sign. I'm just check this. Check this. Check the below one. Check the below one. We'll just check this one. All right. A into A cube, A A square B, and here also again A square B. I'll end up with 2 A square B, and I'll end up with B cube, and this one B, sorry, A, yeah, A square B positive, and again A square B. Yeah, here A3, A square B. Sorry, there you go. I'm sorry. No two. It's one. I'm sorry. Yeah. Then positive A square B. See, A3, then A square B negative, AB square, that is positive, AB square, right. Then BA square, that is positive, B square A negative, right? B square A negative plus B into B2, B3. See the relationship? It's nice, right? It's giving very the relationship. A square B positive, negative. They cancel each other. They cancel each other. Sorry, this one. These two cancel each other. And B square A, B square A. Yeah, these two cancel each other. Finally, I'll end up with this A3 plus B3. So my assumption or my what we call my suggestion is true. And with what we learn here, we can summarize. We can summarize A3 plus B3 can be factorized to A plus B, A square minus AB plus B square. Third, see another nice relationship we derived here. Then, from the theory what we learned here, we can directly derive the relationship for this. Or else, we can use same fundamental approach to get a relationship for A cube minus B cube. So first I'll do the manipulation or do the calculation with the same fundamental approach. Next, I'll explain you how to derive the expression for this one from what we found out here. Again, now my requirement is to find out a relationship for this. So let's find out. Let's see the below. So I'm just going to check below relationship. That is, I'll write A minus B. Why? Because my given form or given problem is in this nature. So I'll write the fundamental basic form of the given problem, and I check. I'll multiply it with this form of expression of this nature, and see what is the final outcome. What is the final outcome? Right. A2 is A3 and plus A square B plus AB square minus A square B minus AB square minus B3. See, okay, another nice relationship we got. Oh, you are getting. This is here AB square. It's with positive sign, and here AB square. I'm sorry, A square B. I'm sorry. A square B is with positive sign, and my A square B is with negative sign. They are getting right off. Here AB square is positive sign, and here AB square is the negative side. Again, you can write them off. So finally, I'm getting A3 minus B3 as the expansion of this. So now we'll work with inverse in the sense, I can say this equals to this. Since I ended up with this manipulation with this, so that I can say, right, this equals to this. So my final finding gives me this relationship. Now we found a relationship for A cube minus B cube in simple form, but then you will ask me what we can do to this, right? This second order form by quadratic form, we don't have any direct factorization because it's not having direct factors. Oh, that I cannot further factorize this in this with this nature. So that these are the best possible factors for a cube minus b cube. Even though we started with third order, we are ending with one linear and one second order factor. So it is easier to find out the solution if this is given in an equation. So that unknowns we can find out. Why? Because dealing with cubic is a bit complicated than dealing with quadratics or linears. Right. Now we found out the relationship between the relationship for a cube plus b cube and a cube minus b cube. See, even we no need to do this manipulation. We did that to understand or train ourselves for mathematical calculations or manipulations. But see here, instead of positive b, if I consider as negative b, I hope you can see that red one. So I'll write in notes. This is not b. Yeah, negative one. So I'll replace all b's with negative b. It's like, so let b equals to negative b. All the places I'll replace b with negative b. So a cube plus minus b cube equals to a plus minus b a square minus a minus b plus minus b square. Yeah. Then I'll expand possible terms, and you know here b minus b into cube means b cube and minus 1 cube. Minus 1 cube means minus 1 cube means minus 1 multiplied with minus 1 multiplied with minus 1. Minus 1 minus 1, I'll end up with positive 1. Then positive 1 again multiplied with negative 1, I'll end up with negative 1. So it's odd power. Odd power. 3 minus 1's odd power is again negative. Means this I can write a3 minus b3 simply. And here again I'll remove this bracket. So minus comes out and I can write like a minus b. Here a square, no manipulations we have done, but negative a into negative b. If negative into negative multiplied by negative is positive, so it ends up with a b positive. Here negative b multiplied with negative b. So it's like b multiplied with b and negative 1 multiplied with negative 1. Negative 1 multiplied with negative 1 means positive 1. So the final answer is b square. See? So with same finding, here we deduce this relationship. Right. So if you get this concept understood, no need to remember both the combinations, only this is enough. And not only that, I'm going to explain you the relationship, how a cube plus b cube expansion you can directly write logically. So we'll see the logic behind this. So the relationship, we'll analyze the relationship. So if you get the mostly in maths, nobody is expecting to by heart theories. So uh, mm, write somewhere and by heart, it's not possible with maths. You have to understand the concept, and you have to you should know the concept and how to apply and use that concept is the fundamental of mathematics. Nobody is asking you to by heart mathematical formulas. So it's not the general practice, and it is not the practice at all in mathematics. Right here, A plus B. Try to understand the logic. You keep that logic in mind. A plus B cube, A cube plus B cube, all right. First, we'll write the linear combination of same. That means first order term of the same relationship, A plus B. When the negative comes, yes, here they are also, yeah. A minus A cube minus B minus cube, yeah, we write the linear form of the same given expression, that is A minus B, the first order. All right. Next, definitely there should be two terms or second order term. Why? Because this here the order is 3 or the power is 3. So to get A into 3, this A should multiply it with another A term and another term, A term, or two A terms for A square term. That is the logic. So then we know that you have to remember your second term is, you have to understand the second term is quadratic form. Then definitely it should contain A square and B square terms. And if this is positive, the center term is negative of multiplication of these two terms. Negate of multiplication of these two. That is the logic. But since here in A minus B, first term is A minus B, since we have to change the sign at the center, here it is positive. Here it is positive. Here it is positive, and here it is negative. Here it is negative, and here it is positive. That is the logic. That is the logic behind cubic addition and subtraction. So addition of cubic value, cubic terms, the two cubic, the binomial, you can say binaries, so binomial, not binaries, binomials. These are known as binomials. If they are having two terms, then we call them as binomials. It's three terms, then it's trinomials. That way, the terminology changed. It's all changing. Right. Hope it's clear to you. So we'll see some exercises to digest the concept. I'll list this. Okay. Let's try to solve this. That is example 1. 81x cube minus 3y cube. 81 x cube minus 3 y cube y cube. Right, we supposed to, or we asked to find out or simplify this. Simply they say simplify this. Simplify this. Or just say simplify this. Simplify then the expression. Simplify then the expression. All right. So it's cubic terms, right? Then we should arrange, rearrange. So we should manipulate and get this into cubic form. You know, yeah, 3 directly I'm not seeing any cubic form of 3. It's irrational number I'm getting, or rational number I'm getting, but so far we have not learned to deal with that sort of thing. So what I'll do is, yeah, I know 81 can be divided with 3. 81 can be divided by 3. I know if I divide 81 by 3, it is 27. So what I'll do is, I'll take 3 as a common value. Then here I'll end with x cube minus y cube. Right. Again, I'm having a constant of, the coefficient of x3. This is known as coefficient, the fixed value. So constants going with variables are known as coefficients. 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 Right. So coefficient of my x3 is 27, and yeah, now we should think. Right, my purpose is to convert this into cubic form. And now, right, what is 27? How can I express 27 as a cubic expression? Yes, I know. 27 is 3 into 9. 9 is 3 into 3. 3 into 3 into 3 is 27. So simply I can write 27 is 3 is, or 3 raised into power 3. Or 3 is 3, third power index. Or power, whatever the known terms we learned in all levels, yeah, it's power into 2, or 3 is into 3. Yes. Then what I can do is, here I can write 3x into 3 minus y3. Directly you should write this. You should train yourself to get this stage directly with your mind calculations. Yes. Now I know this is a form of cubic difference. So simply I can write 3, then 3x minus 1. Same linear form. I'll erase this to any explanation. Right. Then what we know is, what we learn is square of this, that is 9x squared. Then negative of this multiplication, that is 3xy. Multiplication is negative 3xy. So negative of negative 3xy is positive 3xy. Then square of this term. So my negative y into negative y is positive y square. Correct. This is the factorization of, or simplification of this given expression. See, I'm ending it 3 factors, so 3 terms. So if you want to find out this unknown, then if any relationship given, then you can find out. This. Copy this and I'll give you 2 minutes, 1 minute. Let me want to fill any missing live show items. Once you finish, then we know this. Right. This one, the second one. Later I can write in one line. This is x minus 1 over x. Then next one is square of x square. Multiplication of these two and change the sign. Multiplication of these two ends up with multiplication of these two ends up with 1. x3 cancels with x3 in denominator. I know, I think it's clear to you. And change the sign, that is 1. Then square of the next term, that is 1 over x. This is enough. This is enough. Even if you want, you can simplify it further, but simplify up to this level is enough. Yes. Then third one, same of the other side, that is x3 plus 1 over x3. Yeah, directly you can write the answer on stage. X square minus 1 plus 1 over x3. Right. Fourth one. Yeah. The fourth example, 8a3 plus bc plus into 3, the whole bc term into 3. All right. Here, now the constant or the coefficient of x3 is 8. We should convert that a into third power of some number. We know 2 into 2 into 2 is 8. 2 into 2, 4. 4 into 2, 8. So 8 simply I can write as 2 into power 3. And directly this line I write 2a into 3 plus b plus c into 3. We are writing this. Then same standard form, that is 2a plus b plus c, that is my first factor. The next one is twice of this raised to power 2, that is 4a squared. Then negative of this multiplication minus 2a b plus c plus square of this term, that is b plus c square. Why I selected this sort of example is to train you to simplify further. because if you get this nature problem, a problem of this nature, they are not expecting you to keep this as the final solution. If your final solution contains another one or two or half, depends on your mark allocation, so that you have to further because anyway, what we'll write is simplify. So we have to simplify further. All possible simplifications we have to apply. Right. So what I think here I can simplify this further. But this I can write like 4a square minus 2ab minus 2ac plus this expansion is b square plus 2bc plus c square. Right. So what I'll write is 2a plus b plus c. Then all square terms I'll write together 4a square plus b square plus c square. Then ABC the single terms, the multiplication terms I'll write next 2ab plus 2bc minus 2ac. So this is my simplification of final answer for this expansion. This is the possible simplification of A3 plus B plus C into 3. Okay, I'll erase this side. Right. One more exercise. Example 5. Simplify. Simplify a cube minus 27 b minus c cube. Simplify this. We're supposed to simplify and find out more simple relationship to this given expression. Right? Okay. We write the same one. A3 minus 27 b minus c3 here. From our previous exercises, we derived that 27 is equals to 3 into 3. So what I can write is this equals to 3b minus c whole thing into 3. Then the common expansion or common or standard relationship a minus, right? If you are writing directly this second term without braces, you have to think, okay, minus sign is outside the bracket. So now I am expanding directly. So minus into positive 3b, then minus into minus, it's c plus c. So most of the time, we are missing marks of not handling this properly. So that repeatedly I am telling, keep in mind and give more attention and concentration when you are expanding this nature braces, brackets. Right, next one is the second or the a into 2, then this the positives of this multiplication. So it's 3a B minus C. Then row plus 3 into 2 is 9. B minus C into 2. Yeah, right. Right. Here I can further simplify this. So I'll write this as is. Then I'll try to simplify this. Okay. A plus 2, 3AB minus PAC plus here 9. This expansion is B squared minus BC twice into 9, that is 18 BC plus 9 C squared. I'm directly writing. If I'm training, you should to follow same mind calculations and same method because you know I already discussed that combined with the paper 1, the first section, the first 10 problems. Yeah, those are very easy, but it's tricky that you have to manipulate, you handle the time properly. So that you should know this sort of mind, you should use these sort of mind calculations and speedy and simple methods. That's why we are training you here. Right. Then A minus 3B plus C. Then all square terms together. A square plus 9B square plus 9C square. So try to understand or try to grab the pattern I'm writing. So that is a good practice. I'm not saying it is must and that the pattern is not contains any marks in your final answer, but it's a good practice. Then 3AB minus 18 BC minus 3CA. So the cyclic way I'm writing AB, BC, CA. And A, B, C, this sort of things are known as cyclic way. Why? Because that when you are dealing with vectors and some third order problems, so trinomials, we supposed to write this miniature so that easily we can understand the pattern, especially when we are dealing with vectors. But fortunately, we are not dealing with the vectors of this form or three-dimensional vectors. If to advanced mathematics, we will deal with three-dimensional vectors. In three-dimensional vectors, most of the time, we are following this pattern. So it is easy as to visualize the behavior. Right. So I will erase this. Previous one. Before moving into next section, if you are having any doubt, you let me know. If not, I will give you few homeworks just to refresh your knowledge and warm up your brains. In after next few days time, you can try these exercises because then you will recall the same theory what we discussed, and so recalling is must or necessary to remember concepts. Maybe later on I'll do a session on how to remember things and how to memorize things. The pattern, the way our brain memorize, or keep or handle our memory. How they are keeping the long-term memories, how they are keeping short-term memories, and why we are forgetting things. Because we should understand how our cognitive system or brain system works. We know that, then we can do or we can practice that nature to keep the necessary things in long-term memory and unnecessary things flushed out. Right. Okay, I'll use this. So I'll give you some homeworks. You can copy it down. But these things I'll give you a combined tutorial, but these are the warm-up exercises for as homework. But later on, once I complete all this algebraic things in bridging discussion, then I'll give you some comprehensive exercises as a tutorial. Homework 1. Factorize A plus B 3 plus C 3. Then same, right? This is Roman 1, this is Roman 2, this is under the key number 1, the main number 1. Show that A3 plus B3 equals to A plus B cube minus 3 AB A plus B square. A plus B. Then 1. Using the above results, using the above results, factorize this A cube plus B cube plus C cube, sorry, C cube, A cube plus B cube plus C cube minus 3 ABC. So using the above results, you have to factorize this. A cube plus B cube plus C cube minus 3ABC. Right. This is one of the good approach or good exercise. You can try your own. And next time I'll discuss. So I'll give you the answers. Next time I'll give you the answers. And if any tricky things or difficult things, then we can discuss. Those things. Right. Next on the cells. Part 2 and part 1. 6x. This is factorized. Yeah, this is factorized 6x squared minus 55x plus 126. 6x squared minus 55x plus 126. Then second one, all you supposed to factorize, right? Factorize. You're supposed to factorize. Then A plus B plus C into 2 minus 3A plus B plus C minus 28. The third one, we need to find out factors. 10, option is A plus 2B square plus 21 A plus 2B 2A plus, so 2A minus B minus 10 2A minus B square. Hope you can see this. Yeah, I'll retake this. 10 A plus 2B whole thing square plus 21 A plus B. One term is A plus B, the other term is 2A minus B. Then next term is minus 10 2A minus B into square. All right. Then fourth one, x squared minus A plus 1 over A square. So A plus 1 over A into x plus 1. You're supposed to factorize these things. Then 5, 18A cube 30, so 3A square B 10A B square. Then 6 x squared minus y squared minus x minus y. Then 7 x 6 minus 27. It's 1 x 6 minus 27. Then 8 x 6 plus y 6. X 6 plus y 6. Then 9 1 over A3 plus 1 over B3. 1 over A3 plus 1 over B3. Then 10 125 A3 minus 64 B3. I'll read them if they are not properly seen them. Yeah, first one is okay. First one 6A. Okay, the problem is factorized. 6A square minus 55x plus 126. The second one is A plus B plus C whole thing square minus 3 into A plus B plus C minus 28. Then third one 10A plus 2B into 2 plus 21A plus 2B into 2A minus B into 10 2A minus B whole thing square. Then fourth one x square minus A plus 1 over A the whole thing into x plus 1. So we have factorized it. Then fifth one 18A cube minus 3A square B minus 10AB square. Then sixth one x square minus y square minus x minus y. Next one, seventh one, x into 6 minus 27. X into 6 minus 27. All right. Then eighth one, x into 6 plus y into 6. Y power x power 6, y power 6. The ninth one, 1 over b, sorry, 1 over a cube, 1 over a3 plus 1 over b cube. 1 over a3 plus 1 over b3. Tenth one, 125 a cube. 125 a cube minus 64 b cube. 125 a cube minus 64 b cube. Right. Okay. I'll give you 2 minutes to correct your copy. Okay. I'll leave this name. Now we learned about simplification of factorization of algebraic expressions. Then now we'll discuss about okay, the equation term came in previous discussions, but we'll find out what is exactly what algebraic equations. What is exactly algebraic equation and what are the things we're supposed to do there, right? Before that, okay, not before that, yeah, there, as a start, we'll think, or we'll recall our memory about lowest common multiplier. What is lowest common multiplier? What is lowest common multiplier? O, LCM. If we abbreviated this, and most of the time we are using this abbreviation LCM. Yeah. We know in integers, with numbers, numerals, numbers, we are finding the lowest common multiplier by factorizing the numbers. For example, let's say, find out lowest common multiplier for 5, 25, 12, then let's see, yes, 6. We asked to find out lowest common multiplier for 5, 2, 25, 12, and 6. The meaning of lowest common multiplier is the smallest number which we can divide from all given numbers. What is the common divider? Common divider for all given numbers. That is the meaning of lowest common multiplier. The lowest common multiplier, that is the meaning of lowest common multiplier. Yeah, so we'll recall the concept used in numerals, then we'll expand that to algebraic expressions. Yeah, so what we are doing is we'll try to factorize the numbers. So we'll try to express the given number with multiplication of lower numbers. So 5 we cannot okay. 5 we cannot further divide. So what I can do is 5 I can write like 5 into 1. I then 25, yes, I can factorize further, that is 5 into 1. 1 is not needed exactly most of the time, but I'm just writing this to explain. Okay, 1 also there. But most of the time that when we are adding with 0, we are not visualizing or we are thinking that 0 is there. And when we are multiplying with 1, again, we are not thinking the 1 is there. But 0 and 1 are the most important numbers in our number system. 0 is the most important number. And 1 is the second most important number. Later I'll discuss about the other ones. So that even though they are most important, we are not considering them. But we have to give the most possible attention and importance to those two numbers. Because, 0 is the number which does not change the addition or subtraction. 0 is the number which does not change the value of addition or subtraction. And 1 is the number which does not change the value of multiplication or division. 1 is the number which does not change the value of multiplication or subtraction. So later on you will understand the importance of those two numbers, 0 and 1. In mathematics, 0 and 1 are the most important numbers. There are some other numbers later on we can do them. So that's why I am giving that importance here. So why I am writing like that is to give you that training, right? But I'm not expecting you to write 1 in your exam problems or exercises. But here I'm writing to explain you the importance. Because even though you are writing that 1 and 0, you have to keep in mind the importance of those two numbers. Right. Then 12 I can write like 3 into 2 into 2 into 1. Yeah. Then 6 I can write like 3 into 2 into 1. Right. Then what I'll do is here I'm having 5 and 1. Here I'm having 5 square and 1. Here I'm having 3 and 2 square and 1. Here I'm having 3 and 2 and 1. Now I'm going to consider, right, what are the candidates for generating my lowest common multiplier? What are the candidates? 1 is there, 1 is common to all. Okay, we have to take 1 from all these combinations. Okay, 1 is one candidate. Then 5s, we'll consider 5s. Okay, 5 appearing here, 5 appearing here, no 5s here. So the biggest number 5, because that the number what I'm going to select should divide from all given numbers. So that 5 is divided by 5 square. So the possible candidate is 5 square, not 5. Why? Because if I select 5, then 5 square is not 5 square is not divided by 5. Sorry, 5 is not divided by 5 square. Again, then 3. Here 3, here 3. The 3 is common and in first order term. So we'll select 1, 3. And then 2. 2 appearing in 2 locations as 2 square and 2 into 1. So then the common multiplier, lowest common multiplier, that means that the lowest number which can be divided with all two given numbers, that is 2 to 2. Then, so now we have to select that, we have to check the combination. While now we address 5s, so 5s we already addressed, all 5s addressed, and 1s addressed, and 2s addressed, 3s addressed. So that, so the number, the lowest common multiplier is what? Let's see. We'll start from bigger number, the highest numbers, 5 square into 3 into 2 square into 1. Okay. So this combination gives me the possible lowest number which can be divided by all given numbers. That is 5 into 5 to 85 into 3, 75 into 4, 300. So 300 is the number. 300 yeah, 300 is the number. Yeah, here the 300 is the number. Yeah, 300 is the number. Why? Because that if I take 150, 150, I cannot divide by 12. Yes, 300 is the number that which can be divided by all the given numbers, and it's known as lowest common multiplier. 300 is the lowest common multiplier. Right. That is the method what we are using it to for numerals. But now we are one stage higher. So mostly we are dealing with expressions, not numerical values, but we are dealing with numerical values as well as expressions. But we should train ourselves to handle expressions. All right. I hope this concept clear to you, and then we'll move to next stage where we are going, how we are going to handle the expressions and find out lowest common multiplier for those expressions. Right. So, let's take this example. Find lowest common multiplier for below relationships. Below relationships. Right. No expressions, whatever, let's say expressions. Whatever convenient to you, then you can use that term, but time to time with different problems, they are using different terms. The first thing is 8x cubed. 8x cubed, and then 12x5, yes, 12x5. Next term is, yes, 18x7. Those are the expressions given, and we supposed to find out the lowest common multiplier for this expression, these expressions. We know. So, yeah, same way we'll factorize. We try to segregate into the factors, or how we'll try to see. We'll try to see how they built, how they made up. Right. 8x3, I can write like it is. So this time I'm not going to write 1. 8 into no, 8, I can get for the factor has is 8. So I can write like 8 is 2 into 3 is 8. 2 into 3 into x into 3. Right. Then 12x5. 12x, sorry, 12x5, it is 12 is 2 into, sorry, 4 into 3, 4 is 2 into 2. So I can write like 2 into 2 into 3 into x5. So, right? Then 18x7, 18x7, 18x7. Right, 18 is 9 into 2. 9 is 3 into 2. Then I can write like 2 into 3 into 2 into x7. 9 into 2 is 18, but 9 I can express as 3 into 2. Right. So this is the distribution. So this is the distribution of each candidate, each number or each expression. Now we'll try to find out LCM for or lowest common multiplier for these expressions. Right. Okay, we'll think about 2 first. Yeah, 2 is 2 appearing as 2, 3, 2, 2, and 2. So for all possible 2's, I can select 2 into 3 as my lowest common multiplier. Then 3, the first expression not having or does not contain 3, but second and third it contain 3, but then out of that 2, the 3 into 3, 2 is the lowest common multiplier for 3. Right. Then x3 terms, x terms, x3, x5, x7, out of that x7 is the lowest common multiplier for x3. So, lowest common multiplier, I write it here, lowest common multiplier for given expression is 2 into 3 into 3 into 2 into x into 7. If I get the combined number of this the combined number of this, it can be divided by any of the given expression. So that is what known as lowest common multiplier. Alright, so what will simplify this. 2 into 3 is 8, 8 into 2 into 2 is 9, 8 into 9 is 72. This is 72 x7. 72 x7. 2 into 3 is 8. Sorry, I'm sorry. 2 into 3 is 8. 3 into 2 is 9. 8 into 9 is 72. 72 x3. So 72 x3 is my not x3, I'm sorry, x7. 27 x7 is the lowest common multiplier of this. Means now you got an idea that if we supposed to find out lowest common multiplier for mathematical expressions, we need to factorize it and get lowest common multiplier for each factor and multiply it. Get lowest common multiplier for each factor and get multiplied them. Right. By knowing or by understanding the basic concept or fundamental concept, we'll do another example and try to understand further on this application. Now we are given find the lowest common multiplier for below expressions 2x2 minus 8 3x squared 3x squared plus 3x minus 6 and 6x squared. Yeah, I'm using all quadratic equations to simplify the analysis, but this can further expanded to any nature, any order. But here the most here as well as in our advanced level syllabus, mostly we have to deal with second order terms. Rarely we get fourth order or third order, but that for third order or fourth order too can be simplified or expressed in second order terms, because at advanced level, we supposed to deal with second order and not beyond that. Third order and fourth order introduction is there, but not the manipulations. Right. Okay. So we'll try to factorize each of the expression and try to see common factors. Yes. 2x x squared minus 8. I can take 2 out, then within bracket or the inside I'm getting x squared minus 2, 4, x squared minus 4, 4 means x squared minus 2 squared. Directly I can write this as x plus 2, x minus 2. Right? See, I took 2 out, then inside the bracket I'm ending up with x squared minus 4, 4 is 2 into 2. This is like difference of squares. Then difference of squares expansion is this. So directly I factorize it. Right. Then this one 3x squared plus 3x minus 6. Yeah, here 3 into 6 is 3 into 6 is 18. Then I have to get factors of 18 to get 3. I know plus 3. That is 18 is 6 into 3. So I can write plus 6 and minus 3 as the middle term. So how I'm going to write is 3x squared plus 6x minus 3x minus 6. No change. Then I'll factorize. And factorize means that here I can take 3x out. Then I'll get x minus x plus 2. Then here I'll take minus 3 out. Then again x plus 2. Then factors are x plus 2. Yeah, 3x minus 3, or else I can take 3 also out. 3 x plus 2 x minus 1. Yeah, even maybe you tell me, right? Okay, why didn't we take 3 out? Yeah, we can take 2 out initially. That is, if 3 is common to all terms, then x squared plus x minus 2. Yes, That was correct, but I just wanted to show you the complicated. I want to train you to handle complicated problems. That's why I introduced this segregation or differentiation. This differentiation, how to get factors in that manipulation. Right. Then 6 square plus here 6 square plus 6x. So answer is minus. Right. Again here either you can take 6 out, 6 is common to all, or else you can factorize. So this time I'll take 6 out, right? Then it is x square plus x minus 2. Right. Then directly I can factorize 6 x minus 2 x plus 2. All right. Then, okay, these are the factors of each of these expressions. Each of these expressions. Okay. Sorry, this further I divide 6 into 2 into 3. Since we are handling factors, we supposed to find out should be x plus 1. Yeah, x plus 1. Yeah, sorry. Yeah, it's possible. Yeah. So yeah, dealing with factors. Yeah. Then we see what are the common factors. Right. Okay. Numerals 2, 3, 2. So 2 should be selected. Yes. So I'll cross these 2. Then 1, 2 is there. Then next one 3. Here not 3 is not appearing here, but between these 2. So I have to select 1, 3. We also addressed. Then factors x minus 2, x plus 2, x plus 2, x minus 2. So from these 2, I have to select 1 x plus 2. So x plus 2 I selected. So I will cross this. Yes. Then x minus 2, no x minus 2, but x minus 2 here. So I will cross 1 x minus 2 and I will select this. Next, x minus 1, x plus 1, no is sharing, so we have to take both the terms. So lowest common multiplier for this is, I have to take 1, 2, then 1, 3, then 1 x minus x plus 2 term, then 1 x minus 2 term, then 1 x plus 1 term, 1 x minus 1 term. So this is my lowest common multiplier. Then anyway, you will say, okay, this is x minus x square plus 2 square. This is x square plus minus 1 square. Yes, you can write like that. Otherwise, you can keep this as this. So if you want to simplify this, you can directly write 6 x square minus 2 square x square minus 1. That is the lowest common multiplier for the given expressions. Right. So this is the way we are dealing with lowest common multipliers for algebraic expressions. The same concept what we are using with numerals or integers or numbers, but with difference when we are, or the different feeling we are getting when we are dealing with some algebraic correlationship. So now variables. That's why I wanted to introduce this here. I think it's clear to you. And if you have any doubt, you let me know. Otherwise, we will do a few exercises to grab the concept properly. Right. Most of the time, the lowest common multiplier is used when we are simplifying fractions. When we are simplifying fractions, especially the algebraic fractions. So we are having one lesson called partial fractions in first unit. With partial fractions, mostly we are applying this lowest common multiplier, and our knowledge on lowest common multiplier is very important. Otherwise, we are not getting the correct answer, and most of the time we are ending up with wrong answer. So that is why I introduced this lowest common multiplier concept with the algebraic expressions. All right, I'll erase this and we make such few examples to clear ourselves how to apply the learning concept. It is given like this: simplify, simplify, simplify. Then this 1, 2, yeah, 2 over x square minus 1 minus 2, 3 over x minus 1 square. We supposed to simplify. We supposed to simplify in the sense, right? We should combine these two fractions with these fractions, algebraic fractions. We need to simplify these or combine these fractions and try to represent or try to present this in the most possible simple manner. Right. In this sort of exercises, first of all, we have to get, we know that we're supposed to get the common denominator. In with numerals, we to follow the same, right? So that we'll try to find out the lowest common multiplier for these two. So before that, what we do is we factorize this: x minus 1, x plus 1, minus 3, x minus 1 square. Then we know common factor. First exercise, I'll do the intermediate step for you to clear it. The next step we will not. Right here, factors are x minus 1, x minus 1 square. So x minus 1 square is the common factor for both the terms. Next, x minus 1. So x plus 1 appearing here but not here. So we have to take x minus 1 square as well as x plus 1 as my common factor. Now my aim is to make a common denominator. So this is the lowest common multiplier for my denominator. But here also same I have to write. Right. But in maths we know when we are dealing with fractions, if we are doing anything, to one either denominator or numerator, we have to do the same thing to the other. If we do some manipulations to numerator, especially when we are dealing with fractions, it's multiplication and division, not addition. So if we multiply numerator with something, if we have to multiply the denominator also with the same thing to make the expression unchanged. Right. In the same theory, right, we multiplied my denominator with 1 x minus 1 term, because I multiplied with 1 x minus term, that is why it ended up with x minus 2 x minus 1 term. So what I do is I'll multiply the numerator with 1 x minus 1 term. Alright. Then this is unchanged. Here x minus 1 square term goes there and now I introduced x plus 1 term. So numerator 2, I have to multiply with x plus 1 term. All right. Now, my denominator is common. My numerator sharing the same parameters, so same values or same expressions. So we know if my numerator is common, if it is common, actually I'm saying this. If my denominator is common, if it is common denominator, we can take it as a common denominator, or it can take it to one as one number, one variable or one expression. So I'll write it like this: x plus 1. Then numerator I'll simplify, separate. So this is 2x minus 2 minus 3x minus 3. I hope you understood the one-stage manipulation of signs and multiplications. And I expect you are having that ability in this stage. Right. Then I'll simplify the numerator, that is 5y minus 1 minus 5. So minus x minus 5 minus x minus 5. Denominator is x plus 1, x minus 1 square. Otherwise, I'll take minus sign out. I'll take minus sign out, that is minus x plus 5 over x plus 1 x minus 2 square. So x plus 1 square. This is my simplification of these two fractions. This is the simplification of the given factor. So now I hope you understood the application of common or lowest common multiplier. So lowest common multiplier, then common denominator, then simplify the numerator as we get to it. You know, maybe later on we may end up with some quadratic or some third order, fourth order terms, but you can simply simplify that. Right. I guess this we will discuss another example. Two over 1 plus x, 2 over 1 plus x plus 1 over x minus 1 plus 3x over 1 minus x square. 2 over 1 plus x plus 1 over x minus 1, 3x over 1 minus x squared. Right. Here I'm trying to use different manipulations and different understanding. That's why I use this. See? Yeah. Here, I know I cannot factorize this further and this too. I cannot. But here I can factorize this as those squares. See? Yeah. I'm having big small confusion here. Even I know in glance I can understand these two terms are bit equal, but not exact. Here, one appearing in positive form and x appearing in negative form. Here, x appearing in positive form and one appearing in negative form. So that I have to make these two in this nature, either this or this. Means I have to change the sign of this term. Means what I am going to do is this. Sorry. Negative 1 over 1 minus x plus 3x 1 minus x 1 plus x. Right. Now, okay. Now, I know 1 plus x common lowest common multiply is 1 plus x. 1 minus x lowest common multiply is 1 minus x. So both the terms, the lowest common multiplier is 1 minus x 1 plus x. So now I eliminated that intermediate with calculation of intermediate line, and I'm doing the calculation in one line. Here 1 plus is there, 1 minus x is missing, so I have introduced 1 minus x minus 1. Here 1 plus x is here, 1 plus x. Here 1 minus x is here, but 1 plus x is missing, so I have to introduce 1 plus x. Here both terms are x, so I don't need to add anything. Right, then I'll simplify 2 minus 1, that is 1, then minus 2, minus 3, positive 3, 0. Right? Minus 1, sorry, minus 2, minus 1, minus 3, plus 3, 0. So only 1 remain. And here either I can express as 1 plus x, 1 minus x, or 1 minus x square. All right. I'll erase this. Yeah. Then I'll give you some homework. Then for you all, yourself, and see whether you can handle this properly, this methodology properly. Homework. It's like the first one is but bit complicated, not that much. If you follow the theories, you can easily solve this. I'll write first, then I'll dictate it. The first one is 3 over x squared plus 2x plus 15. X squared plus 2x plus 15 minus 1 over x squared minus x minus 6. 1 over x squared minus x minus 6 plus 2 over x squared plus 7x plus 10. X squared plus 7x plus 10. So you have to simplify. The homework, let's simplify. below. Second one, second one is 1 over a square plus ab plus b square multiplied with 2a over a cube plus b cube multiplied with a4 into a2 b2, sorry, a4 plus a2 b2 plus b4. Here the denominator is 4a square. Very simplified, right? Maybe you have to find common denominator, you have to find some factors, you have to factorize it, you have to use whatever theories we learned so far and get the most simple form of these given expressions. Yeah, next one. A square plus b square over a square minus b square. A square plus b square over a square minus b square minus a square minus b square over a square plus b square divided by this side is this is divided by a plus b over a minus b minus a minus b over a plus b divided by a plus b over a minus b minus a minus b over a plus b. Next one. I write both and explain you. Right. Yeah. Then fourth one, 2 minus y square plus z square or c square, whatever the way you pronounced. If it is American way z, and if it is British way z, y square plus z square minus x square over y z. Oh yes, y square plus c square minus x square over y z. Divide by 2 plus x square plus y square minus z square over x1. Oh yes, x square plus y square minus z square over x1. And fifth one, a square plus 3a plus 2, a square plus 3a plus 2 over a square minus 4a plus 12, a square minus 4a plus 12 multiplied with a square minus 7a plus 6, a square minus 7a plus 6 over a square minus 4, a square minus 4, a square minus 4. Right. Those are the homework exercises we plan to give you. And right. We'll discuss the other things next day. Right. Hope you understood what we discussed so far, and especially this lowest common multiplier for algebraic expressions. Then this scale of difference of scales, then addition and difference of cubes, and their common expressions or their further simplifications. You have to remember in the sense you have to understand the logic, and you should grab the logic of that, and then the common the lowest common multiplier and how they are applying in algebraic expressions and simplification of algebraic expressions, especially the fractions of additions. Sorry, addition of fractions and multiplication of fractions and division of fractions. Right, okay, that we supposed to discuss today, and right, we'll wind up the class for the day now.